to students. I guess your preparation is at the top for your upcoming board examination, and also you are worried for your upcoming practical examination as it's knocking your door, right? So maybe you are not having the proper idea what you are going to face in your practical examination, how to represent your practical copy. So everything with full hacks and tips I'm going to explain in this video, and later on I will also perform each and every practical for you people. Yes, I will perform, I will show you how to do it so that it can help you a little bit, even if you are not there in your lab, but still you will understand what to do whenever a salt or something, a titrant will be given to you, what to do, how to perform a experiment, and how to write, how to analyze the data. Okay, so let's at first proceed with some secret tips and strategy that can give you full 30 to 30 marks in your practical examination. So first that I'm going to tell here in the volumetric analysis part, you can get two different titration. Either you can get KMnO4 and oxalic titration, oxalic acid titration, or you can get KMnO4 and more salt titration. Any one of them you will get. Okay, so what you have to do, you have to prepare the solution of the oxalic acid, if it is oxalic acid, if it is given. Okay, then 100 ml M/20 oxalic acid, this particular strength may vary, but usually this thing comes, it's a standard procedure, and calculate the molarity and strength of KMnO4 that you have to find out. Okay, next, if you are having KMnO4 versus more salt, then same thing, 100 ml M/10 more salt you have to prepare. Okay, and molarity and strength of KMnO4 solution, that also you have to find out. So let's see how you should proceed. So this is the points you have to remember for your writing in your practical copy in your examination. First, you have to aim, you have to write the aim. Okay, at the very beginning, at the top of the copy, you have to write the aim, right? So aim is something that will be given in your question paper itself. So here you can see that whatever the volumetric analysis, this particular thing, the volumetric analysis of the KMnO4 versus oxalic acid, this particular thing will be given in your question paper. So from the question paper itself, you can write down the aim. Okay, apparatus and chemical required, it is optional. Ask your examiner. If he or she tells you to write it, then please make sure that you are writing it. Okay, now molecular equation and ionic equation, both you have to remember. Ask your examiner that what they actually need. On the basis of that, you have to write the proper balanced equation. Okay, make sure you are remembering the indicator. So indicator, actually here I'm using KMnO4, it's a self indicator, so you can write that only. End point calculation is very much important, that also you have to make a proper table and you have to do it. Observation part, definitely solution in burette, that is of KMnO4, and solution in titration flask, that is oxalic acid versus more salt. Okay, so these are the part of your observation. Okay, so next here you can see this is a proper table. Please make sure you are carrying your own pencil, own eraser, own scale, own pen. I have seen so many of the students there literally asking to someone else for the pen, pencil, eraser and all so many stuffs. So please don't do this. Be self-dependent, don't depend on your friend. Okay, because in the practical examination your impression matters a lot, because whenever the examiner will come, he is from the outside, right? External we usually call them, right? So he is from the outside, he doesn't know you, right? So your impression, your overall impression during the lab, it matters a lot. Okay, so make sure that you are carrying your own things. Okay, so here this is how you have to maintain the table in case of titration. So serial number, volume of oxalic acid if it is given, or more salt it is given, so that you have to maintain. And here burette reading, initial reading and final reading. Please make sure don't write ml here and here. Okay, here it will be reading only, but whenever you are writing here volume used, that is final minus initial you are doing, then you write the ml. Okay, here you don't mention the ml. Okay, so whenever it comes to the initial reading, let's say you are starting from the 0, you ended up, let's say just randomly I'm telling, let's say 12.4. Okay, so again you can start your titration from the 12.4 and all, you can continue. Okay, so first reading that is taken, it is a rough reading. It is a rough reading, first one. The first one basically, it's a rough reading. Okay, so this is just to understand in which point you will get your like close by point where you can get your end point. So make sure that your end point is very, very faint pink colored. Okay, make sure that you are putting one white paper just below your conical flask. Okay, I will definitely show you during the lab session that you will soon get the videos of the practicals as well. So the very faint color is needed for that. Okay, so make sure that your color is not dark, your reading will be messed up otherwise. Okay, and once you get knowledge about like in which volume you will get the end point, then this 3 reading will be your concurrent reading. This 3 reading will be your concurrent reading. Okay, so please focus on these 3. There should not be difference in between, like in between these 3 readings by 0.2. Okay, 0.2 difference is okay, but just take the average of these 3 and that will give you the volume of the cheminophore consumed. So this is all about your table. Okay, next let's proceed. Here what you have to do at first, that more salt you have to prepare. How you should prepare? See, we know the formula of molarity is basically molecular is given weight divided by the molecular weight into volume of solution into 1000. Volume of solution must be in ml. So put the value here. Here you can see whatever the molarity they will give, m by 20. M by 20 means basically 1 by 20. Okay, weight you have to calculate into 1000. Okay, divided by molecular weight of more salt is given 392. Okay, into volume of the solution 250. Right, so now from here you can calculate W. Okay, you can calculate W out of it. So that particular amount of more salt you have to weight, and then that thing you have to put it into a 250 ml volumetric flask, and you have to like pour water and you have to make a homogeneous solution out of it. Okay, next part what you have to do, the final and most important part, to calculate the strength and the molarity of the cheminophore. Okay, so that formula you know, N1 M1 V1 equals to N2 M2 V2. This particular N is called N factor. Okay, let's say this particular thing, this N1 V1, this particular side is known. Okay, this particular side is, let's say, for more salt. Okay, and this particular side, let's say, for cheminophore. Okay, so everything you know out of it. Okay, so N1 for the more salt, let me just write it down. N1 for more salt. Let me write N factor so that you can remember it. N factor, first for more salt, it's going to be 1. Okay, N factor for cheminophore, just remember them, it is basically 5. And N factor for another one thing you can expect is more salt, cheminophore, or you can get oxalic acid. Oxalic acid. For oxalic acid it is basically 2. So these N factors you remember. So let's say I am doing the titration with respect to this thing, with respect to more salt. Okay, so here everything I know. So N1, let's say it is 1 into M1 you have calculated, it was 1 by 20. So 1 by 20. Volume that you know, usually 25 ml or 10 ml, whatever the pipette volume that you have, that you will pipette out, that particular volume you have to write. I'm just writing pipette volume, pipette out volume. Okay, that also you know, it's known, right? Okay, now N2 is definitely for the KMnO4, that's going to be 5 into M2 you have to calculate, and V2 from the table. Okay, so this is how actually you should proceed with your calculation. Now once you will get the M2 value, that M2 value you put here molarity into molecular weight of KMnO4. Molecular weight of KMnO4 I guess 198, that you can multiply with this, that will give you the amount in gram per liter. Okay, so this is how the calculation will proceed. Okay, so here in this case just result you have to write it like this. So molarity you can write it here the way I showed you the calculation, and strength you can write it here. Again you write molarity and strength and put the values here. Okay, precautions, 2 to 3 precautions you please remember. If your examiner asks you to write the precautions, then don't forget to mention them. Okay, next let's proceed with the next practical, that is the salt analysis. Usually these cations are given, okay, high chances are there, and anions you can expect these. Okay, most importantly let me just mark carbonate, SO4 2 minus, Cl minus, another one let me just write Br minus you can get. Okay, so these type of anions you will get out of it. Okay, so let me just show you how actually you should maintain the entire thing. If you already have done, you are finished with your record, then already you know the pattern of writing. So make sure you are writing the aim like that from the question paper itself. Now at first what you have to do, you have to start with a preliminary test. Okay, so preliminary test, whenever you are writing, make the column 4 consecutive column, 1 for serial number, experiment, observation, inference. Okay, so whatever the test you are doing, like preliminary means basic test, okay, without using any chemical, without doing anything, how I can analyze or how I can sense what kind of cations or anions is there. Okay, so here you can see by looking at the color, smell, dry heating, flame test. Okay, this, but whenever you will get some sensation that these salts may be present, I mean these particular cations are present, maybe there is a possibility. So please make sure that in inference part you are writing may be present or may be absent. Okay, make sure with respect to the test, here in the inference you have to write may be present or may be absent, because preliminary test cannot tell you these are obvious. Okay, it will give you the idea how to proceed further, that's it. Okay, let's proceed. After the preliminary test you have to proceed with the identification. First identification, once you get the preliminary idea, then you have to proceed with the proper idea, I mean you have to proceed with the actual identification of the radicals. So first we will proceed with the anions, means acid radical. Okay, so here you can see this is for the acetate anion test. Okay, so dilute H2SO4 test and concentrated H2SO4 test, it has been done here, and here you can write the present, or here there is no chance to write the absent, because if it is absent, why I should proceed, right? That's the reason we do the preliminary test, so that these may not be present, those are eliminated. Okay, chalo, we will not proceed the identification test with these cations. So to identify which are not necessary, we do the preliminary test. Further, once we got the idea, okay, these can be present, we will proceed with the identification. So I got the idea, okay, acetate can be there from the preliminary test, now I will proceed with the identification. So identification I will do with respect to acetate, and here I will write the present. In the inference we will write present. Okay, it's not yet done. Then what you have to do? You have to write the confirmatory test. Identification is done, this particular thing is there. Now you have to confirm it further. In the confirmatory test, at least 2 you have to write. Maybe you are performing 1 in your lab, but at least 2 you have to write. Okay, so here you can see either FeCl3 or oxalic acid test you can write, and here in the inference what you have to write? Confirmed. Okay, please make sure in the inference portion you have to write confirmed. So how you should proceed? Once again, just a small recap. At first, start with your aim, then preliminary test, basic test, so that I can get the idea which cations or which anions I have to proceed and which I don't have to proceed. Okay, there I have to write maybe present, maybe absent, like that. So I got a basic idea what I have to perform further. Then we will proceed with the identification test. Okay, so once identification test will be done, here we will write in the inference it is present. Next, in the confirmatory test, what do we have to do? We have to write it is confirmed, it's present. I guess you understood this. So this is for the acid radical. Then what you have to do? You have to proceed for the cations, means basic radical. So here you can see identification of the basic radical. So for this particular test, Pb2 plus is present. So Pb2 plus is basically group 1 cation. So in this case, just group 1 reagent is given and Pb2 plus is present. Okay, so in case you are having something in the group 5 from group 4, okay, then you have to proceed, you have to start from the group 1 itself. Okay, you have to show that group 1 is absent, means you have to give that HCl, dilute HCl you have to give, and you have to tell that okay, there is no white precipitation, Pb2 plus. Don't write Pb2 plus, write instead group 1 cations are absent. Next, proceed for the group 2, write the reagent. No observation, no that type of observation, group 2 is absent. Group 3, proceed with group 3. If you can see group 3 reagent, it is working, maybe aluminium or something, if that type of thing, you will get it in group 3 itself. Okay, then you write, okay, aluminium 3 is present. Okay, this is how you have to proceed step by step. So cationic radical, whenever you are writing, then it's a little bit tricky. You have to start from group 1 itself. Sometimes you will get it. If in case you are very lucky, you will get lead, then okay, fine, you got lead, then in group 1 it's done. But sometimes barium, aluminium, calcium, magnesium, for those cases you have to further perform. Right, that I will show you in the video how you should actually further perform the test. Okay, so in those cases you have to write and you have to show it that these are absent, these are absent, these are absent. That's why we further proceed, and okay, group 4 cation is present, like that. Okay, let's proceed further. Once you got your cation identified, then write with the confirmatory test. Again, 2 confirmatory tests are mandatory, so write it. Here you have to write it is confirmed. Pb2 plus is confirmed. So this is how you should proceed, and here in the result part, please make sure you are writing what is the basic radical you identified, what is the acid radical you identified. So whenever I will do the practical, and I will show you at that time also that whatever actually you have to write, whenever we will see, we will take some group 4, group 5 salts as well. That time I will show you how actually you have to mention in the cationic portion, cationic radical or basic radical, how actually you have to make the table. Okay, then it will be even more clear to you. I guess this case also it is quite clear. So now I will discuss about some mistake that you must avoid during your practical session. First, external examiner, whoever, like definitely your internal will be there, your one of your practical teacher will be there with you, that's a very good thing, but one teacher will be there who will be from outside, right? So in that particular case, whatever the instructions are given inside the lab, please make sure you are following them with your humbleness. Okay, next you can see submitting incomplete or unchecked record. It creates a very bad impact on your record because it carries 4 marks. So please make sure that you are writing all the records, you have finished your record, your practical teacher has signed on it, and then make sure you are writing your roll number, you covered it with a proper thing, and then you are submitting it. Okay, next, please my dear children, be humble. Okay, maybe you don't know anything about the practical, but still your behavior will talk about your nature. Okay, if your examiner is good, then your behavior will help you to get better marks. Okay. Next, not writing the steps correctly in the practical exam, that's gonna be very hectic, because how you are representing in your copy, it's going to be the most important. Maybe you are not done anything in your lab, you can't do, you don't know the steps. It's okay, if your examiner is good, he will or she will help you out, but you have to know what steps you have to write, how you have to proceed. That's the reason I am telling you, please practice writing by giving 2 to 3 mock tests at least. Okay. Next, spoiling your shit. So I have been an invigilator, being there in the practical laboratory itself, I have seen so many of the students, they like spoiled their sheet, like by, you know, whenever the entire chemical will be poured on the particular sheet, and by your friends by mistake, anything can be happen, right? So once the sheet will be given, it's a fixed with a code. Okay, it cannot be changed. Okay, so make sure you're protecting it properly. So keep it inside your drawer or at a safe place, so that any kind of chemical pouring and all these things you can avoid. Okay. Next, you can see forgetting lab coat and shoes. Please, my dear students, don't forget your lab coat, because safety first, and these are the major rules whenever you are entering inside a practical class. Okay, and that will tell you how much generous you are. Okay, so please make sure you are wearing your lab coat and you are wearing your gloves if needed, and you are performing your practical. Carry your own things with yourself, so that you don't have to ask from your friend, and be humble in your lab. Okay, and whenever they are asking the question during the viva, please make sure that you are not getting confused. If you don't know it, just tell them you don't know it, and if you are having your any chapter that is you are having proper confidence, please tell them that I am confident about this chapter, and they will ask you the question about it. And at the last, just let me tell you one thing, my dear, no one, I wouldn't say that no one, rather most of the cases, 80 to 90% of a student, they get more than 25 in the practical examination, and the rest of the things depends upon you, how you are maintaining the decorum in your practical classes. So that's it, my dear. So please make sure that you are watching the upcoming practical videos, so that you can get enough confidence for your practical examination, and don't forget to like, subscribe and share this video for the more information and some knowledge, hacks, tips, everything for your upcoming examination. Thank you so much.